Hello everyone, today we want to talk about Dijkstra's two-stack algorithm. So what is it? It's also known as a marshalling yard method. Is an algorithm for evaluating arithmetic expressions. This algorithm was proposed by Edgar Dijkstra in 1961. The basic idea of the algorithm is to use two stacks, one for operands and one for operators. The algorithm iterates through the expression from left to right, processing each token, digit, operator or parenthesis one at a time. Depending on the token type, the algorithm takes different actions. So, in our code, we need to solve this arithmetic operation. As you can see, what is operand? Operand is our numbers 5, 1, 2, 4, 3. What is operation? Operators. It's arithmetic operations. It's a plus, multiply, minus, divide. It's so. In here, we need to solve this with help of Dijkstra's two-stack algorithm. So, in the first, evaluate expression. In this method takes an arithmetic expression as a string and returns its result as a decimal number of type double. Stack double operands. Create the stack for the operands, our numbers, from the expression. Stack character operates, creates stack for the operators, operation signs from the expression. And the loop 4, it iterates through each character as soon as possible. Check if the character is an open parenthesis, it's a disabled. Operators and operator checking if the real symbol is an operator plus, minus, multiply, divided. So it's a push it on the operator stack. And if the current character is a digit, it's converted to numeric value and push it onto the operand stack. So as you can see, remember validation, if the current character is a closing parenthesis, the operators and operands are pulled from the stacks, the result evaluated, and the result is pushed back onto the operand stack. Next, in a while loop continues until the statement stack is empty. Popping operator and operand from stacks, pops the top operator from the operator stack and the corresponding operands popped from the operand stack, performing an operation depending on the operator fetcher from the operator stack. The corresponding arithmetic operation is performed on the two operands. In this, in a private static double perform operation, we need, as you can see, we have 3 values: operand D1, operand D2, and character operator. So this code defines a static method named perform operation. This method takes 3 parameters. So operand 1, it's the first operand of the operation, the second operand of the operations, and the operator to be applied to the operands. And then we have a switch statement. Inside the method, there is a switch statement that evaluates the operators. Cases of the operators. Case plus. If the operator is plus, the method returns sum of operands 1, operands 2. Case minus. If the operators is minus, the method returns the result of the subtracting operand 2 from operand 1. Case is multiply. If the operator is multiply, the method returns the product of operand 1 and operand 2. If this case is divide, the method returns the result dividing operand D1 and by operand D2. And the default case, if the operator doesn't match any of the cases plus, minus, multiply, divide, it throws a legal argument exception. Invalid with message, invalid operator. So we can run it, this code. Let me show you. As you can see, result will be 14. you can solve this by yourself. So what we understand to this, the Dijkstra two-stack algorithm works as follows. It's a first initializing stacks. Two stacks are created, one for operands, one for operators. Tokenization, the expression is broken down into producer tokens, digits, operators, parentheses, processing each token. If the token is operand digit, it's a push it onto the operand stack. If the token as an operator, it remains on the operator stack. If the token is an opening parenthesis, it's a lost. If the token is a closing parenthesis, pops operators and operands from the stacks, then the operation success and the result is pushed back onto the operand stack. So results of the operations are pushed back onto the operand stack, as we can say, returning the result at the end of the algorithm. Only one element remains on the operand stack. This is the result of evaluating the expression. All operations are performed according to generally accepted operating and the parentheses processing prioritize, ensuring proper processing order and the correct results. This method provides efficient evaluation of arithmetic expressions, using stacks to store operands and operators and executing operations continuously. So, thank you for your attention. See you next time.